Well, hey there, Joe. Welcome back
Hey,
to the
thank you.
Making Math
It's been
Moments
a
That
while.
Matter podcast. It has been a while. Like if we, I mean, luckily, when you were first on, it was episode 10. So it makes the mental math really easy here because I
Yes.
think this is episode 290 that is going to be coming out. And I don't know, I don't have to do any carrying, nothing. I know very quickly that we're talking about 280 episodes ago of weekly podcasts, and you're
Isn't
back
that amazing?
and you're still doing amazing things in
Well, thank
mathematics and
you.
helping people to push their beliefs, their perspectives, and their understanding of mathematics forward. So, welcome back. How are
Thank
you doing?
you.
Where are you coming to us from? And
I
just fill us in. How have things
I
been?
am here in California on Stanford campus. And yes, I'm going to keep going, even with all the people who are hating on me. I'm
The,
just
the
keep going with
naysayers.
those good maths messages.
This is the good work you're doing. You know that because of that you're making waves in the right way, right? And I think
I
that's
guess, yes,
that's
when the haters come out.
right,
Yep.
right. Like I think someone's I'm making this up or I've heard this somewhere is that like if you're going to do any sort of impactful work, and it's not necessarily education, but it's like something that
Mhm.
if you're making a dent and you're making a wave that's impactful, you don't make friends along the way. And
Yeah.
you've made lots of friends, but you've also got some people coming out of the woodwork to try to push you down
What do
back
the
down.
kids call them? Hashtag haters, I think
Right.
might be
Yeah.
the
I
might be the
have a
description.
whole set of haters. Yeah.
Right. Right.
Yeah.
Come to know them well.
Yeah, as John's saying, I really do think, as much as that is probably not what you were after when you began this journey, the reality is just to, sort of highlight that what John just said. It's so true that you are having an impact and people are getting attention. And that means the people who are loving your work, implementing your work, understanding the work, it's reaching them, but it's also reaching the other groups that
Hmm.
have not had the same shifts. And I'm going to argue that a lot of these individuals that generally are maybe against some of the things we're trying to do in mathematics education is because they are feeling vulnerable themselves, right? When you don't
Yeah.
have a conceptual understanding of mathematics,
Yeah.
what you're doing is you're going, well, I mean, I thought I was good at math, and you're telling me that I don't fully understand all of the mathematics. And I don't like that. That's sort of like a
Hmm.
translation that I feel a lot of people have.
Yeah,
It's
I agree
very
with that.
humbling, and you
Yeah.
have to be humble in order to be able to accept that along the way. And I know I struggled with it myself personally. I didn't go out hating people at the beginning, but at first, when I recognized, and I think we shared it on some of our earlier episodes, I had a math moment myself where I had a professor in second year university say, "You don't know anything about mathematics." And for a very long time, I did not understand what that meant.
You were
Hmm.
And
angry at him. You
only
were angry at
after
him.
I was mad. I was very upset. And I don't think Twitter was around at the time when that happened, but I didn't go around, voicing it openly. But the reality was it took me many years teaching to
Yeah.
actually understand what he meant. And he meant that I didn't have a conceptual understanding of the math. I
Yeah.
was very procedural, and I knew
Yeah.
procedures, and that was it. So
Probably
again,
not the best way to share that with you, but
no, exactly. And we joke about that. I say, I feel like he could have been more helpful in terms of,
yes.
letting me in on the secret there. But I do now recognize at least what it was. So, when we were with you last time, this is many years ago, we had asked you about a math moment, and now we're going to maybe change it up a little bit here on
Okay.
episode 290. We're going to ask you, what's a math moment that you feel has sort of resonated with you over the last 5, maybe 10 years since your Math Mindsets book and since the
Hmm.
last time we had spoken here on the podcast?
I mean, one of the defining moments for me that I still think back on and I've been thinking about in recent years is when I was in elementary school and maths, it was just arithmetic. And I wasn't interested and didn't really engage much with it. And then our teacher invited us to design something as a project. And we had to design something that flew, and we had to research it and make it. And I still remember that project to this day. I was probably 10 when I worked on it, but it meant something to me. I was engaged with it. I cared about this thing I was making. There was maths in it. I loved doing that maths. So I've often thought about that. Why did I not like maths in elementary school? And then I remembered that amazing moment or piece of time we worked on that project.
Yeah. And it's obviously it's stuck with you, and it's probably influenced the work that you do now. Like it can't not probably influence it. Otherwise,
Right.
otherwise we don't remember these things. Like usually these
Yeah.
memories influence the thinking we have, the perspectives we have, the beliefs we have. How do you feel like that influenced, the educator you've become?
Well, I definitely experienced myself lots of maths classes that weren't very engaging for me. I could do it. I could answer their short questions and speed through, but it just wasn't interesting to me. And another really important moment for me was actually when I was older doing A-level maths, which is something we do in England when you're 17, 18. And the teacher was completely different to any teacher I'd ever had before. She would ask us to talk about the questions in groups. And that just changed everything for me. Now, this was this subject we had ideas about and we could connect with other people. It wasn't this solitary, just sit and do questions. So all of that experience really changed me and made me the educator I am. I also remember vividly during my A-level years with a different teacher, when the teacher said, this may be what I shared 10 years ago, I'd be curious to know, but the teacher said, has anybody got any questions? And I said, yes, I have a question. And he said, oh, you have a question about that?
Right.
And I never asked another question.
Right.
No.
I think that you're right. I think that is what you shared. And
it brought back a moment for me, from way back then, because I haven't thought about that specifically. As soon as you started, I was like, oh, I do remember that.
That probably was, because that scarred me.
Yeah.
And
you know what I heard that you shared here is this idea of like, and we hear this coming out in, 290 episodes of people sharing math moments, some positive, some negative, some that, just are the thing that pop into their mind. And the one thing that you start to see is that those people who are maybe thinking a little bit differently than maybe how we may have, quote unquote, traditionally thought about what mathematics class is, was going from this like get done, sort of subject towards a truly constructive, truly engaging, enlightening, epiphany, filled, like a feeling, a moment, an energy, a vibe. And I'm wondering, and I know we discussed this a little bit way back when, but as you were on this journey, like, did you feel like, were you convinced just one day you just went, it should be like this? Or like, describe a little bit of this journey from where you were, because as students who were taught in a fairly, I would say, similar way, I think many of us can relate that you're going to sit and get, and you're going to receive this information. And then you start moving through. I feel like, and I know for me, there was like a shift. And for me, it was engagement right away. I want to engage students, but I went about it as many people do. I used a lot of gimmicky things at first, and I could get them to look my direction, but like I wasn't getting anywhere. Like, what would you say was sort of that maybe moment for you that started to get you to go, there's something different going on here, and I'm starting to maybe see that this can look and sound a little bit differently?
I definitely had that experience in my first years of teaching in London, when I'd had really good training at London University that encouraged us to teach kids through more conceptual maths tasks. And so I was right from my first year giving kids those more engaging tasks. And I could see the different levels of engagement when the maths task was good and when the maths task was narrow and boring. But it's really hit me in recent years. I teach a class at Stanford to undergrads. It's called How to Learn Maths. And I get all these undergrads coming to me who've been very successful. You don't get into Stanford unless you've pretty much excelled in the school.
Right.
Who are completely maths traumatized and maths damaged, I think, of them. Even the successful ones, those who've done well in maths, have done well by memorizing, and they just see maths as a whole list of procedures. And so I work to undo that and give them these creative problems, and ones where we're talking and they're sharing ideas and they're writing things on the walls and we're all talking about maths. And it's so impactful for them. Every year, they're just saying, I just don't want to go back to the other maths. This is really what it is. This is where I'm getting these amazing connections happening and I'm understanding. And so definitely that experience, I as I've gone further and further into my career, I've found more and more amazing tasks that I can share with others. So, and I just see the impact of those. I also find something that's hit me since I've, done more work in maths ed is the best tasks are really the ones that go across many age groups, many grades.
Totally.
I can give my undergrads tasks that fourth graders do, and they can get really super engaged by them, and vice versa.
So it's almost like positioning like the questioning around the task or the scenario that kind of like keeps the learning going or keeps the thinking going, and how deep you can get on a task that may resemble a third grade task, but you can get, high schoolers to engage in that same depth, or not the same depth, but the same task can get to different depths just because, you might tweak something or you might ask it in a different way because it's a different.
Well, they just take it in a different direction.
I want to get into your new book, Math-ish. And, I've read all of your books, and I know like the first book that I read it was, what's math got to do with it? And which was, so eye-opening for me, because I think it was on the crux of trying to figure out, how do I change my math instruction? Like, what is it looking like in my class? And it was like your research-based approach to that book gave us like almost like a nudge, being like, these are the right things to be doing in my class. So I know that book well. I know the new book, and I'm going to skip over the mindset book for a second, because I wanted to kind of like think about that comparison. So I'm going to ask kind of the two questions in one here, which you're not supposed to do when you interview someone, but
we're going to do it anyway.
But I'm going to do it anyway. Is like first, how do the two books, how are the two books, different? Because part of it's like giving a snapshot of like, what are really good practices to be doing in the classroom? What does math should look like? These are some of the things. And you've got some good research in there to kind of support the conclusions, but then also like, where does the name ish come from? Like how is that in there? Like, tell us more about math-ish, but then also maybe fill us in on the continuation of what's math got to do with it.
I think what's math got to do with it? I wrote that book because I'd been presenting research to a group of non-math specialists. I'd actually been on this sort of special sabbatical place with people from all different disciplines. They weren't in education, they weren't in maths. And I was presenting my research, and they came up to me and said, oh my gosh, you have to get this out. This is like, nobody knows this. We all think something different. And so what's math got to do with it really was summarizing research on what we know. I feel that math-ish, I'm at a totally different place in my career, and it's more sharing examples of things that people are doing and that are really working well. But yes, I'm glad you asked me about what math-ish is, because I knew even as I was writing it and having that title that to some people it would be horrible, horrific, the idea of math-ish.
Ish, yeah.
Instead of, math precise. But what it is, I make an argument in the book that in the real world, when we use maths, our answers are nearly always ish answers. So I give some examples, like you could be talking with people and asking how big is the moon tonight, or how much rain fell last night, or how long is this journey, or how much paint do I need to paint this wall? Lots and lots. I could give you a million examples.
Right.
All of them, you would give an ish answer. But in maths classrooms, maths is all about precision.
Sure.
And so I was making the suggestion that we should engage kids more in this ish thinking. It's what they do in the world. And it keeps them at a conceptual level instead of getting into the nitty gritty of the numbers. They're keeping their brain more conceptually, which I know teachers say they have a lot of problems with, that kids jump into number problems and come out with wild answers because they're not thinking about really that bigger picture, what the numbers are. But I soon found, after people started asking kids to ish, so I make a suggestion that before kids ever do a calculation, we should ask them to ish the numbers first, because it does keep them thinking more conceptually, and then they can calculate it and they can see if they're the same or similar. But I quickly found out that teachers who were going out and asking kids to ish numbers, it was opening the students up. Kids who had been afraid of maths class and never engaging was suddenly raising their hands and sharing their ish numbers. And I have a video. I started a website called mathish.org where there's a video of 6th graders ishing together. And they talk about both of those qualities. They talk about, well, ish is what we do in the real world. This connects with us, with the world. This is what we do. But they also talk about, oh, when I ish numbers, it helps me. And one of the students says in the video, we were always told we would do a calculation and then we'd do the calculation again, and we'd have to do it 2 times to check. But now I ish the numbers, and that is a much better way of checking. I don't have to do calculations twice anymore. But the kids also said, none of this is in the book, but the kids said to their teacher, Shelby Craig, that it was really going to help them in standardized testing, and they planned to ish the numbers that they got in the tests. And they came out of the standardized testing saying they totally ished their way through it, and how helpful it was for them, and they got answers quicker. And so, I mean, there's just many benefits. I will say that we've always had this we've always had this thing called estimation in maths.
Right.
We encourage our kids to estimate, but I also know that kids hate to estimate.
Yeah.
And sometimes they just like calculate it exactly and round it off to make it look like an estimate. Like,
that's what Kyle used to do.
That was me as a kid. I vividly remember as a kid,
I'll just calculate it.
And then the teacher would ask me, it'd be like I'd calculate it and then I'd like take 2 off or something, and then all of a sudden the teacher would ask, how did you get it? I'd be like, I don't know, and the teacher was like, okay, and like there was never really any
but that's because the teacher put the emphasis from the get-go that calculating was more important than estimating, right? So it's 100%. Like when you saw part A of the question said estimate, and then you went to B and says, oh, I'm going to calculate it anyway, and that's what the teacher wants. So why am I doing the estimating first? So you just jump right to it and then go back and fix it. But it's like because of the culture that was, where the emphasis needs to be, or was.
Well, you think about how helpful, like helping kids recognize and create the habit, because like a lot of things we do in school, I think the best things that we're doing for students is we're equipping them with tools like thinking, problem solving, like all of these processes.
Exactly.
And this is one of the pieces that, I should automatically be thinking in my head about how much X, Y, or Z I need, if it's paint, if it's, gasoline, if it like whatever it is that you need.
My checkbook. Yep.
Exactly. And it's like, and we're in school doing all of these random problems that, a whole other tangent is about, who wants to actually calculate these things anyway. That's a different discussion. But when it comes to building in almost the automaticity that every time you are about to calculate something, that you actually look at the problem. And I mean, you look at a problem solving model and it tells you to do these things, but it's easier said than done, right? Nobody wants to follow the steps, but you create a habit where you go, oh, and I think about standardized testing and how valuable that is for students to go, well, like B it's not even remotely close. It's like, just get that one off the board. And like you've just increased your ability to, because we're still going to make mistakes. We're still going to, maybe think too quickly or whatever it might be. And just to have that tool in your back pocket is so helpful and so important. And, when it comes to something that we've learned over our time in the classroom was, and I think we got the idea originally, from Dan Meyer. We used to follow his work quite a bit early in our journey, was the idea of withholding information, which helps you to kind of snap that habit a little bit of, I was the kid that if you gave me all the information, I would just skip right over it and I'd go. And there's kids that do that. But if I don't have all the information, now we're all kind of brought to like a common level. We can all be on the same playing field, in that Joe's not going to get the answer before John does because there's not enough information. It's like we can get some estimates and then we can try to use math to maybe make it a little more precise. More, we'll say you'll math-ish it, but then eventually you'll try to narrow it down a little more. Like, how can we get a little more precise, a little more precise? And that's sort of the beauty of mathematics, and sort of why we're doing what we're doing in the end, right?
Exactly. And I think with ish, it is exactly as you say, it's a tool that's going to help us in lots of situations. But what I'm also hearing from teachers is it's helping them open up their classroom and have more kids participate.
Totally.
Really valuing it for that reason.
Yeah.
But yeah, in What's Math Got to Do with It, talking of that book, I share a question that was given in a standardized test. And the question was 7/8 plus 12/13. And kids were asked, is it closest to 1, 2, 19, or 21?
Wow.
12/13 plus 7/8, they're both close to 1. So
right.
It's 2. The most common answer given across the US was 19. The second most common answer was 21.
And there's two thoughts that obviously cross your mind about, I'm following a blind procedure that I know nothing about, or that I truly have absolutely no conceptual understanding of what a number over a number. And I use the word over on purpose because we talk about the fact that it's not even talking about the size pieces, like we could say 7/8 of a whole or whatever it is. And it's like our language sort of allows us to get almost too procedury too quickly, instead of thinking about what is it that we're actually dealing with here when we look at these numbers.
I'm sure the kids, just jump into, fractions. What do I do to add fractions? They add denominators, and I'm also sure they've never ished numbers, because that would give you an easy answer to that question.
Right.
But they probably, have never thought that's allowed to do.
Right. Yeah.
Maths is all about precision.
I want to come back to what you just said there about allowed, because I that's a very interesting thought that I continually think about math education. But I wanted to talk about more ishing, because where I feel like the power of ish is in, and it has to do with the estimation process, is that you're really getting students by like what Kyle was saying, is like holding back the information, getting them to kind of like ish first. You as a teacher, if you're using that technique, and if you listen for the right things, you're going to hear problem solving strategies just naturally show up, right? Like you're going to hear different thinking, which is like complete formative assessment goldmine for you as a teacher, to hear where you think students are on, say, this lesson or this task or this topic, because you're going to go, let's ish through this. And then people are going to have like, imagine that in it, like, it's like reminds me of like sometimes these numberless word problems, where if you ish your way through it, you've built your whole problem solving technique. And then now it's like, put some numbers in, or like, we can be precise whenever we want. But the really important part is figuring out what the problem solving technique should be.
Yeah. Yeah. Totally agree.
Now to go back to what you said about permission, this is the idea that I constantly think about like, you hear this all the time, right? Like you hear kids say, like, that's not the way I'm supposed to do it, or that's not what I'm allowed to do. I didn't know that you could do that. And then teachers say it too, right? Like this is why it's like, I feel like it's such an important topic, because teachers will say, and Kyle and I talk to district leaders every single day across North America. And I always hear them say like, I'm not sure, like or you hear the coach say that the teacher said, like, I didn't know you could do that. It was like allowed to do that
Yeah.
technique or teach that way.
Mm.
Like, I feel like, and I wanted to get your take on it. Like, where do you think like this whole idea of like permission, like I didn't have permission to do it that way, really comes from within?
Yeah, I mean that I definitely see that holding kids up. I in Mathish, I describe a teaching moment which I actually have on video where a great teacher has asked kids to think about what fraction of a shape something is, and it's actually a square divided into quarters with one quarter shaded. So kids are in their groups, but on this square, there isn't all the lines. You see the one quarter shaded and a big square with
Okay.
no dividing line.
Right.
So the kids are in their groups and they're saying, oh, I think it's 1/2. I think it's 1/3. I think it's one, like they're all over the place. And then there's one boy who's totally correct, reasoned really well, and said, but look, if we imagine a line drawn down and across, we can see there's 4 parts and one of them is shaded. And the other kids say, but there is no line. So, and then
You're not allowed to do that.
another one says, yes. And she didn't tell us. She didn't tell us to think like that. She just told us, she just asked us, what is the fraction? She didn't ask us to prove it. And so I'm like, oh my gosh, these kids are so held up by these different ideas about what they're allowed to do. Changing a shape, like by adding lines, is a really mathematical thing to do.
Right.
And we pay a lot of attention in maths ed circles to number sense. And I think of that as shape sense. Okay, I have this fraction question. I'm going to draw some lines so I can see it more clearly. Kids don't think they're allowed to do that. They think they have to work with the shape they've been given. Can't draw lines, same as they think you can't change numbers. If you're given a question like 18 times 5, you have to work out 18 times 5. You don't think, oh, I could work out 20 times 5 and take off 2 5s. So kids who do know that, they're thinking flexibly, they're adding lines, they're changing numbers. So many kids don't know. So many kids that think that's not part of mathematics. It's not the question I was given. They're bound up by these imaginary rules that are really holding them back.
Well, and I love that because it's exactly where I wanted to go. You talked about the imaginary rules, but the reality, when we talk about what math is and then what math looks like in a classroom, it's like there's so many opportunities. John and I recorded an episode recently. John, you'll remember the angles problem that my son had, right?
Right.
And I never cause any, parental issues with my kids and how their teachers teach or anything like that. It's like, hey, we talk as, me and my kids, we talk about what they could have been thinking or whatnot. But, the example I want to give you is this example where the point of this assessment was to determine if they knew how to measure right angles. Okay. And, we're talking like this. I measured it with a protractor because my son was like, this is not a right angle. And my teacher, and I put, it's not a right angle. And it was like 93 degrees. And the lines were thick enough that you could potentially move and I'm like,
a right angle-ish.
It's a right angle-ish. It was like a perfect example of that. And so the reason that popped into my mind as this example is that it's not actually imaginary for the kids though, because it's like they have so many examples of where they get dinged for not following the exact question or exactly what they were said. And you think about a word problem that says one thing that's slightly, maybe not intentionally there to trick, but it could easily trip someone up. And when you zoom out on it all and we go, and I said to my son, I was like, do you know what a right angle is? Tell me everything you know about a right angle, and he tells me all he knows. And I said, so I'm like, could you see why your teacher might think that this is a right angle or not? And yeah, I understand. And at the end of the day, the thought that he had was he didn't know what he actually knew. And it was based on the fact that it was not flexible enough, when in reality, I think as educators, we really have to be aware of what is it that we're trying to learn about our students? What do we want to know that they know or don't know? Because I want to know that too, because I want to help them to get better at it. But how do we do it in a way where students don't start making up a game in their mind because they're just trying to follow the rules of the game? And for
Yeah.
me, I don't know. I mean, I have one way. Making math more math-ish is going to help with that, because what that allows educators to do is maybe to zoom out just a little bit and say, I don't think it was that important. He knew that if it was around 90 degrees, that we're going to call it a right angle. And if it's not anywhere close, and I just wonder, like, when you're thinking about educators and the teachers that you're working with, the pre-service teachers, for example, how do you help them to maybe gain the confidence to help break free from some of these practices that I think are just, they're kind of built in because we went through a very similar system, sadly.
And what makes me sad when I hear this example is I feel like often in maths, kids feel they have to follow like somebody else's rules and their own thinking is not inside it. They don't think it's their job to figure it out themselves. They think it's their job to follow some rule that's been given to them.
Mm-hmm.
And that's not true of other subjects. When they're sitting in English class or history class,
Totally.
you probably think, I'll figure it out. I'll use my thinking to reason about this situation. But in maths class, it's not there. It's not a part of the equation for kids. When I did my PhD study years ago in England, and I wrote about this in Mathish, I mean, in what's math got to do with it, the kids said that the difference with maths and other classes was maths class was not about thinking. And that in other classes, you have to think for yourself about things.
Wow.
And that's kind of tragic, really. But
yeah,
that they think,
I see it too. I see it
do
too.
Do you know what's really sad about that? That I just had this little mini epiphany for myself. It's not a good one either, is that I think that's why I actually did well in math as a student, is that actually I didn't have to think and I didn't enjoy the other classes. I think for the exact opposite reason, that like thinking is hard, and it was about
hard.
Stuff I didn't want to think about at the time.
And I think, I don't know, like, help me on this part, but it's like, I think I heard this too, is like thinking actually burns more calories and your body's like, like your body's job is to actually try to conserve calories to stay alive in a way, right? So it's kind of like, doesn't want to think. And teenagers especially don't want to think. And it's like, so Kyle, like you not enjoying the other classes because you're forced to think and liking math more because you didn't have to think, like it makes sense. Like your body's saying, do that more than that because that's burning more calories than that. And we want to keep you alive longer.
We also have adolescents, and I've interviewed these kids too, who, as they get into their teenage years, particularly, and they're 14, 15, 16, they start to resent being controlled by other people.
Sure.
They want to have their own thoughts and their own values respected in class.
Totally.
I know a lot of kids who reject maths because of that. And I was interviewing kids in calculus classes some years ago, and there was one set of kids, they spoke very eloquently about this, but they were saying, my calculus, my maths class, it's all about control. I just have to do what I'm told to do. And he didn't like that. He was like, basically you sit down and you follow what you're told to do. And it was very much about wanting his own agency.
That is so interesting. And I see a lot of myself in my son. My son is 10, and my son is I would say a very intelligent, child. And he's like a perfect example, and a nice kid, doesn't get into trouble or anything, but he does not enjoy school. And I mean, part of it, I'm sure that he wants maybe more control, but it's like the whole day, I think, to him. And I think I can relate as a student that I just had to get it done. And I think I looked at all subject areas that way. And I think that's why I landed on what's the easiest subject to just check it off the list? And for me, it was math, because I'll call it just lucky that I was able to memorize enough of the patterns to put in minimal amounts of effort and get a result. Whereas if I was a student in my own classroom, in the last, say, 10 years, where I actually am pushing for productive struggle, and I'm pushing for thinking, and I'm pushing for, ish, as I will now call it, I think I would have been my own worst nightmare as a student, at least at first. But when you see kids like me, or like my son, when they're actually challenged to think, and this is specific to math, that's the only area of education that I actually taught. When you see that shift from a student who is like me, it's like, I love it. Like, I just love seeing the light bulb go off, where they go. I had one student, for example, John, I've told you this story. I think I've mentioned it on the podcast, where all of grade 9, this student was a me, and she memorized her whole way through. She won the math award in grade 8, and all through grade 9, she pushed so hard. And she was like, it wasn't as easy. And it was like, the teaching style was obviously different. It was in grade 10. It took that entire year. In grade 10, she stopped me in the hall and said, "Thank you for making me think." Because she said, "I have no clue what I'm doing right now, and it feels worse than ever." And I was like, I was sad for her at the time that she was lost, because now it was back to rules and back to whatever. But it was like, it took that experience for her to get to a place where she went, I guess it was worth it. I guess it was worth doing the calorie burning and the thinking.
Something you're reminding me of, the students who don't want to do this deep thinking work. I was asked a few years ago to teach an incoming class of undergrads at Stanford, calculus. And they were all students who were in a program where you get to come early because of various things. They're first generation, they're different things. But anyway, so we had these 100 students. We taught them like conceptually through thinking and giving them tasks and saying, okay, you found the rule, now figure out why, and really pushing them to think conceptually. And there was a group of resistors who hated it and just wanted to be told why, didn't just want to be told what to do. And they communicated this to us: just tell me what to do. I don't want to think about why. And when we did deeper analysis of the data we collected on them over the next year or so, we found that they were the lowest achieving students. And what we realized was happening was, they'd got as far as they'd got by like memorizing and not really understanding. And now here we were saying, you need to understand. And that made them insecure and them push back on it.
Yeah.
So
it forces them to be vulnerable.
But I thought it was really interesting that it was actually the lower achieving kids who were most pushing back.
I'm gonna stretch the limits here, and in thinking about math-ish and the ideas that you present in the book, and thinking like, where do you see, because you continually talk about changing instruction so students have these experiences. There's a big chunk of the book that you talk about metacognition and how it's so important in learning mathematics. We think about the experiences we want to be providing for our students. Like you are a huge part of the New California framework, and like, what do you see like math going in 10 years in classrooms? Like we talk a lot about like what we want it to look like, but if we start to think about how do we actually see these changes taking effect? Like, sometimes I get worried, like we've been talking, like we talked to you how many years ago? 5, 6 years ago. And it's like things are spreading, but it's like the rate is so slow, right? It's like, so now it's like, imagine 10 years from now. And I want to think about 10 years, and I want to think about like these students that were experiencing some of these things that some of our teachers are putting into place. Some of them are going to become teachers. And then the cycle should get easier. But I mean, like, where do you do you see it soon? What does 10 years look like if we're moving in the way that we're trying to move?
I think if we were moving the way we were trying to move, we would see classrooms where kids for more of the time were working on deeper problems, not just these short questions that they don't care about, where they were working on problems that they did care about and where they got to think and reason and talk to each other. And I certainly see those happening in more classrooms now than I ever have before. And now we've actually managed to get that approach into policy in California.
Right.
Is, pretty amazing, particularly given all the pushback. And I am seeing leaders in districts already putting the ideas into place. In fact, we've already got some data back from leaders who, as soon as we started the process of the framework, so it was like 3 years ago, started doing work with teachers, and now their kids' achievement has shot up. So we're seeing it in place. We're seeing the evidence of it in place. But you're right. It's so hard to change. And it's particularly hard when people fight the changes.
Yeah.
100%.
I mean, I know we have just so much research showing that kids can learn in a better way. And in other professions, I mean, if you look at the medical profession, we wouldn't be in the place where doctors were like, I'm just not looking at that research. I'm going to keep using to get blood out of patients. They would be disbarred. No, that's lawyers, but they would not doctors any longer. But we have this in education that we know what works, and it's hardly happening anywhere. So change is tiny, very, very, very slow. And then I do think it has been made slower by the people who try and block it. And the people who try and block it, I have learned over the last few years, can be very well organized and funded by very wealthy people who are very invested in blocking change. And you talked about how, Kyle, you were saying that maybe it's people who have never thought conceptually, so they don't know what it is. And I think it's partly that. But then, we have a system in the US, I don't know how similar or different this is in Canada, but where kids are basically pushed out of high levels at every opportunity.
100%.
And what the framework was proposing to do is change that system and not be pushing kids out, but having more kids go forward. So there were people who weren't very happy about that because they know how to play the game. They've done it. They know how to get their kids to do it. And if you're taking away their advantage, then they are going to fight that.
Right.
They
100%.
said that to me or about me to people. The super wealthy CEOs in Silicon Valley said, she's going to stop my kids getting to the highest levels. And of course, we're not stopping their kids getting to the highest levels, but we are making it so that more kids can.
Right. Which I guess from a logical perspective, a very selfish perspective, someone like that is going, they do the ish on that in their mind and go, oh, wait a second. If there's only so many spots and my kid was basically a shoo-in because X, Y, or Z, this is
they're just scared.
Definitely problematic.
Yeah. You've said this, Kyle, a long time ago when you started to see changes in your classroom, and when kids start to see it in their rooms and you're trying to change the way class runs.
Like where the field starts flattening. Instead of
it's like you're giving voice to kids who normally didn't have voice, and you're starting to reward, you're in a way trying to get more thinking out into the open. Some of those students who had, Kyle, you used to say, like, it's almost like this game has changed, where I used to be like, this was my subject, where I used to show dominance, like this was my thing, and now it's all of a sudden like the tables are flattening, and now I'm feeling threatened that no longer. And so then the pushback in those experiences has always been from the kids who get 95s, because you're trying to, you're changing instruction to be about these other things, but they've had a lot of success not thinking. And now you're asking to think, and now all of a sudden maybe the success isn't there for them anymore, and there's a threatening happening, and they're going to push back. And it's the same outside of our classroom right now. It's like the threatening is there, and we're going to push back. everybody thinks that they have an opinion on education because they were part of an education system at one point or the other, and they think they know what's best.
Exactly. That is exactly the case. And, most of the opponents, nobody really looked at this, that the people opposing the changes in California were all super successful mathematicians and STEM academics. Nobody questioned, like, is this coming from the cross-section of society? No, it's coming from a group who've been super successful. They don't want mathematicians. There are some, obviously some mathematicians are amazing, but there are some mathematicians who don't like to be told that anyone can be good at maths because they've built their whole identity on the idea that they're special.
You're right.
So there's some high school maths teachers in that group too.
100%. And we've discussed that, in the past as well. And, our last question for guests is always about a big takeaway for the audience. And I'm wondering if I can add a little slight nuance to it here. And I'm wondering specifically for those, I'm going to go ahead and say it, that if you're listening to our podcast, whether it's the first time or the 290th time that you've listened, the reality is it's likely that you are on a journey and you are trying to affect change, and they're trying to follow a lead, like from you there, Joe, and from others in the space who are trying to do great things in math. But you might feel like you're on an island, so some of these people who are listening, they might be the only person in their department listening, or the only person in their school on this journey, and they might feel alone. So I guess instead of the big takeaway here, I'm wondering, what would you want those individuals who are feeling like they want to do the work, but they're feeling as though they're not sure where to start, or how do they do it when they feel that they're sort of alone, looking around and they're the only one sort of pushing this thing forward? And we know what happens if someone doesn't do this work is nothing happens, and then it slows change. So what sort of maybe big takeaway do you have for those who might be feeling that way, or just feeling like the work is just too daunting in their context?
Well, one thing I suggest to teachers who are just, not in this place at all and are beginning is maybe to try some of these more open creative tasks, maybe once a week, maybe every Friday. Kids are working on tasks that are different and richer, and start with that. You don't have to overhaul all of your teaching, but try it. Maybe try it once a week. And I found that can help teachers. I do think if they're the only one, that's really hard. And one piece of advice I would give to people in that situation is find the other people, whether they're online or in your region. Find people who you can talk to about it and connect with. And we have a UCubed Facebook group, actually, and I love that space. It's got over like 30,000 educators in it, and they're a like-minded group of people, and they use each other as colleagues and resources. So don't be alone. That's really hard to make changes when you're alone.
That's a good message for sure. Joe, we want to thank you so much for joining us here on another episode of the Making Math Moments That Matter podcast. I know that the book Math-ish is in all the places you get books, and I actually appreciated you recording the audio version.
Oh, yeah.
That's how I listen to it. So I listened to the audio version. So it was great to hear your voice talk about all those things. So anywhere else you want to point people to kind of reach out to you, or kind of learn more about the work you're doing?
Anybody can reach out to me. My email is super easy to find. The easiest one is probably joeboaler@gmail.com. But I've recently made mathish.org. So you can, on that website, there are some things in the book that I've made into beautiful glossy handouts on the website. So
love it.
Awesome. We will definitely put links to the resources. We won't post the actual Gmail. We don't want it to get scraped by your favorite friends that are out there these days. But those who are listening, you heard it from Joe, so don't be a stranger. And I love your message. Reach out to people. Relationships is key. It's key with our kids.
Yeah.
And it's key with our colleagues, right? Those who are trying to do the great work with, because if you feel alone, you can, your mind tells you all kinds of crazy thoughts. So, lean on somebody to try to get some real, objective thoughts and feedback. So thank you, Joe. It is episode 290. You don't have to wait another 280 episodes, by the way. We would love to have you back sometime in the future and to catch up to chat all things math.
All right. I will be at OAME. I don't know if that's
OAME, yes. Kyle says it differently, but
I say oh whammy. I just like pronounce it. John doesn't like that. He's from
OAME. It's the letters. You spell the letters,
I love it. So 2025 then? 2025.
All right, we'll see you there.
Awesome. Looking forward to it.